In this problem, we're using the rational zeros theorem to find all the possible rational zeros of a function. And remember, the method for doing that is we take all the factors of the constant term and put them over all the factors of the leading coefficient in all the combinations that are possible. And the only trick about this one, I think, is that there are going to be a lot of combinations, and we want to make sure that we don't have any duplicate answers, numbers that are really the same thing in a slightly different fractional form. So we want to remove those duplicates from the list before we finalize the answer. But let's start here by listing the factors of our constant term. So we'd have 1 and 9 and 3. And of course, we could have negative values of all of these too. So I'm going to put a positive negative in front of each one of those. And then the factors of 6 would be, and let's do the positive negative, 1 and 6 and 3 and 2. All right, so let's start placing these factors over these factors in all the forms we can think of. So I'm going to just start with the 1 and place them over each of those. So 1 over 1 would be 1, so I'm going to write that as a positive or negative 1. 1 over 6, so that's a positive or negative 1/6. 1 over 3, so positive or negative 1/3. And 1 over 2, so positive or negative 1/2. Okay, so far so good. Let's go on to the 9. So 9 over 1 would be a positive or negative 9. 9 over 6, well, that would simplify to 3/2, so positive or negative 3/2. And 9 over 3 would be positive or negative 3. And 9 over 2 would be positive or negative 9/2. And let's see. So far, I don't think we have any duplicate values. Let's go on to the 3. So 3 over 1 would be positive or negative 3. And I've already got that right here, so I don't need to write that. 3 over 6 would be, well, that would be 1/2, and I've got that here, so I don't need to write that. And then 3 over 3, well, that would be 1, and we got that right off the bat. And then the last one, 3 over 2, well, I've got that right here. So it turns out all of those with the 3 I've already got on my list. So my final answer would be this. So that's a little more practice with using the rational zeros theorem.